Okay, this is 11.2, page 172, question 3. Paraphrasing. We have, go to pen, we have a couple of tangents, SP, touching the circle at that one point there. That is clearly a radius because it's passing through the centre 0 or the centre O, so let's just put a 90 there. It could be useful. Here's another radius, therefore that's 90 degrees, and these are all isosceles triangles. I know it looks a little bit like a boiled egg. I sort of squashed it a bit there. Never mind, that's what we've got at the moment. It says calculate angle RSO. That's RSO. Well, straightforward, it's 22 degrees. Nothing to say about that. These are two identical triangles there and there. They're congruent. They have the same radius. They have the same length because this length here is identical to that length there, because we have two tangents meeting at a common point S, and therefore we've cut it straight in half. So there we go, 22 degrees. That's that one done. Angle POR. POR. Well, that's that one there. I knew these 90-degree angles would come in handy because look, I've got a 44, I've got two 90s, and I've got this angle POR. As you can see, I've got a quadrilateral. It's not cyclic, but it is a four-sided shape. It's a lovely kite anyway, isn't it? And cut it straight in half, one line of symmetry. So essentially I've got 360 degrees, take away the 44 that I've created, take away the two 90s, and that will give us an angle, an obtuse angle POR. Just do that quickly. So 360, take away 44, take away the 90, take away the other 90, and that leaves us with 136 degrees. There you go. Beautiful. And now calculate angle PQR. PQR. That's all of this. Now, be careful. We know this is an angle of 136 degrees. Is that all right? Now, this is the angle at the circumference. Sorry, the angle at the centre. If you imagine me drawing a chord down here like that, joining P to R, not very straight, but forgive me. So here I have an obtuse angle at the centre, coming off chord PR, and now I have an acute angle at the circumference, also coming off the chord PR. And the angle at the circumference is of course half the size of the angle at the circumference. Angle at the circumference is half the size of the angle at the centre. So therefore it's going to be 136 degrees over 2. 68 degrees. Absolutely peasy. I mean, I can do it, but I can't always say it, you know, because it's not planned. I'm just like getting on with my maths like I was doing it for myself. But here I am on vid doing this stuff, and I hope it's all good. Right, next question. Plonk. Right, still grade B. In the diagram, blah blah blah, lots of words. Essentially, they're describing this scenario. I know that OQ is a radius because that's the centre of the circle, so that's the same as that, and therefore that's an isosceles triangle. Very straightforward, isn't it? I'm not going to read the question. If that's 80, then basically I've got 100 degrees left to share between angle Q and angle R. So essentially you're going to get 50, and you're going to get 50 as well. So I've got two 50-degree angles. That's lovely. By the way, what's the question? Oh, prove that triangle QPR is isosceles. QPR. In other words, this must be the same length as that. I can't prove it, but if I can prove that this angle here is 40 and that's 40, hey, we're up for it. We're up for it. So look very carefully. OQ is a radius. QP is a tangent. Therefore, this angle is 90 degrees. Let's begin to prove it. OQP, our angle OQP equals 90 degrees. Why? Tangent to the radius. And therefore, what have I got here? I now go 90 degrees, take away 50 degrees, equals 40 degrees. Again, it's me fully writing out the proof. So therefore, RQP is 40 degrees. Let's say it then. RQP, so angle RQP is 40 degrees. Angle RPQ, going the other way, is also 40 degrees. Therefore, triangle QPR is isosceles. See, that's the first time I wrote it all out, didn't I? So there you go, there's your proof for grade B. I proved that QPR is isosceles. Straightforward. Now, what's the next one? To get more dodgy. Yes, it is. What a mess. This is grade A rated. What have I got here? I've got a tangent XAY right across there. It's touching at the point A. I've got an isosceles triangle, a big one there, and I've got a littler triangle here, ADC, also isosceles, but different from triangle ABC. Different form of isosceles, different lengths, different angles, etc. I'm told angle XAB is 48, and now I've got to calculate angle BCA. Alright, BCA. That's that one. Now, got it straight away. Look, tangent touching a chord forming an angle in this segment. In the alternate segment, in the other half, well, that's a much bigger half, in the other segment of that circle, I now have the alternate angle, which is 48 degrees also. So straight away, angle BCA, 48 degrees. Give you reasons, alternate segment. I don't know why I'm writing that, I'll just say it, can't I? Now, angle ABC. ABC. Very straightforward. I've got an isosceles triangle now. If that's 48, then guess what? That is also 48 degrees. Alright? Isosceles. The two base angles are 48. Therefore, B is going to be, ABC is going to be 180 degrees. Take away two lots of 48, and this is what we get. So 180, take away two lots of 48, gives me 84 degrees. So there we go. And what's the reason for that? Isosceles triangle. That's that one. And DAC, they want this one. Okay, let me try and do this one now. Okay, well, I've seen it. Angle ABC, this one right here, is 84 degrees. Put an 84 there. Now look, we have opposite angles in a cyclic quadrilateral. Just think outside this little box. Eradicate that line from your mind. It's not there. Look at this. A, B, C, D. Cyclic quadrilateral. So if that's 84, then this angle here is going to be, let's just go to black, stands out better. It's going to be 180 degrees. Take away the 84, which is something. And I always say that, but it will be something. There it is, 96 degrees. That's what you call opposite angles. In a cyclic quadrilateral are supplementary. They supplement each other up to 180 degrees. So that's my proof for that. That's my reason. So I've got angle DAC. I'm going to get that in a minute. So I've got angle D, so it's rather CDA, as 96. So I've got another isosceles triangle. So I'm now going to work it over here now. So therefore, angle DAC is going to be 180 degrees. That's a triangle. Take away the 96. And then divide by 2. So here I go, 180, take away the 96, divide by 2. That gives me 42 degrees. Alright, how did I do that? Well, isosceles triangle. ACD is isosceles. So that's all the proof you need. And that's all the angles answered. That's me explaining all the bits and pieces. Now, do I have space or time for one more? I can't see how long this video has been going on for, actually. Do one more, then we'll see how we feel about it. Yeah, make this the last one. It looks really tricky. This is A star. A star. So let's just look at this really slowly. Right, what have I got here? PC and QC are tangents. Yeah, okay, see where I go. That's a tangent, and QC, that's a tangent coming right across the page. Let's just extend that a little bit. There you go, tangent. Right, blah-de-blah-de-blah, lots and lots of words. Essentially, I've got to work out X and Y. Remember to show you working. Alright, let's think about this. Oh, isosceles triangle. You're the same as you, and you're the same as you. So these are also Y's, and that's an X. And I've made a start. Oh, look, you are a tangent, aren't you? Which means if you're a radius, then you must be 90 degrees. If you're 90 degrees, I can work this little part out. So here I go, doing it fully now. I'm working out angle ABO. So angle ABO equals 180 degrees. Take away the 90, because it's the radius to the tangent. Take away the 82, and that will give me angle ABO. So it's 180, take away the 90, take away the 82, and that gives me 8 degrees. That's really skinny. So if that's 8 degrees, then angle BAO is also 8 degrees, because it's an isosceles triangle. Me fully doing it. So that's an 8, try and put it in, and that's also an 8, try and put it in. 8 and 8 is 16, I've got X straight away. Therefore X is going to be 180, take away 8, take away the other 8, and that's the leftovers for X. It's a very obtuse angle. So 180, take away 16, leaves me with 164, yeah, 164 degrees, and that's that. Now what about this Y thing? Okay, that's 164. I better write it in straight away. That's another 90 degree angle there. Yeah, what I think I'm going to do is work with that one and that one and that one and get this one here. Now look, this angle here is going to be something, I promise you something. It's going to be 360, take away that 90, take away that 40, take away that 90. So here I go. So angle BOC is going to be 360 degrees, take away the two 90s and take away the 40. Take away 90, take away 90, take away 40, because essentially I have a four-sided shape, a quadrilateral, it's a kite, and now we're going to work out BOC. I'll need that in a minute. So 360, take away the two 90s, which is 180, and take away the other 40. That leaves me with 140 degrees. So let's just write it in. Now look, I've got 140 there and 164 there. So if I combine these two, I can work out the angle inside this last isosceles triangle. So I'm now going to work out up here, I think. Yeah. So angle AOC this time is going to be 360, take away 64, take away 180. So let's just do that. 360, take away 164, take away the 1. Did I say 180? Sorry, take away 140. At least I wrote it right. So 360, take away 164, take away the 140, and I have 56 degrees. So that is 56 degrees. Now, it doesn't look very cute, does it? But it is. I have to obey the maths rather than that. Let's work out angle Y. So angle Y is going to be 180 degrees. Take away the 56 degrees there, and then divide by 2 because I've got two Y's. Let's just do that. Now divide by 2. So each base angle is 62 degrees. Alright, I'm going to stop there because that's been long enough, and I'll be back in a mo.